operators, along with EPRI, the Electric Power Research Institute of the United States, and Eurelectric, the European Federation of the Electrical Associations of Europe. It is an honor to open this second platform for this year, and we are targeting during the morning and in the afternoon in session 1 and session 2, how to target a net zero and coupling resilience with grid modernization and expanding prosumer market. Tomorrow, there will be a supplementary session for the first time in the platform, which is devoted to watching the Mediterranean coasts and southwards. So Africa and the development of distribution grid in Africa. So I have now the task, obviously, to give you some housekeeping rules. You can place your question directly through the platform or the chat at the bottom right. Please direct your question or answer to everyone, so everybody can see and appreciate. Indicate your name and company institution when posting your question if it is unclear from whom is coming. And the moderator will select a couple of questions and ask the relevant speakers or panelists to comment, or will bundle the homogeneous questions in order to optimize time. Raise the hand feature will not be activated for this platform. You find at the bottom of the slides the hashtag and the Twitter references and handles of the organizers of these conference, and the hashtag and the Twitter account of the conference. So for those interested in tweeting, tweeting is allowed and free. The speaker will have in the panel an allotted 10 minutes time. It is also requested time for the opening keynotes, and when my big face will reappear on the screen, you are about to expire your 10 minutes. So it is a kind of a gentle suasion to go to the conclusion. So without further ado, then, welcoming you another time, on behalf of the three organizers, I would like to give the floor to Christian Buchel. Christian is the chair of E.DSO. He is executive board member and the director for customers, markets, and territories at Enedis, the largest French distributor. His keynote speech will concentrate on evaluating the European effort to take the lead on the smart grid technologies. Christian, you have the floor, please.
Thanks, Roberto. Good morning, ladies, gentlemen, dear colleagues. I think I can say dear friends. I see a lot of friends all over the world. All of you connected now from everywhere in the world. Let me first wish you all a very nice and a very happy year here from Paris. Welcome to our second Global DSO Platform annual conference. Last year, we sat together to discuss the state of distribution grids. It was across Europe, Asia, and the Americas. We talked about investments, technologies, and strategies that we, the grid operators, need to favor the energy transition to serve at the end, our customers in a responsible, but also in an efficient way. This year edition prepared, and I would thank EPRI, Eurelectric, and E.DSO. This year event is dedicated, is still, I would say, a challenging one first, since on top of the pandemic, energy prices soared to the top of the political, both at national and EU level, by member states and commission leaders here in Europe. The reason was an unexpected surge in natural gas prices coupled with insufficient renewable energy production. The gas and power prices spike in many countries here and over the world, causing outrage for customers and immediate concern and sometimes very strong reaction from politicians. We could say also all food distribution system operator with E.DSO are not implicated in causing the surge of energy prices. We remain, however, very concerned since this crisis poses a direct threat to the sustainability of the electricity sector and indirectly to the proper functioning of the European wholesale electricity market. More concretely, the rising energy prices led to increase in DSO's grid loss costs because the DSOs have to absorb the entirety of prices increases without the option of recuperating the cost from client or public resource who are the primary beneficiary of the increase of such wholesale energy prices. But maybe more importantly, the fear of blackouts is real among our end consumers, who in many countries are hardly affected by the increase of these prices. As you all are aware, DSO business model in Europe relies on tariffs set well in advance by our national regulatory authorities to finance investments, especially those investments we do need to tackle the energy transition. However, DSOs are frequently impacted by governance models and government measures. Therefore, it may occur, happens. Can you hear me? Yes? Yes, it may occur that authorities in some states can make political decisions to protect the customers by reassess this tariff or reassess some elements of this tariff. Consequently, the crisis urges us to consider how important it is to combine both market design and climate targets to elaborate on an affordable system for the end consumers while assuring the massive investments needed in the whole electricity value chain from generation to the customer side through the grid network. So it is essential to develop these topics bearing in mind the current scenario in Europe. As DSOs, we are already managing smart meters and smart grids, giving households more control over their consumption. But the current increase in energy bills must not compromise, and there is a risk, must not compromise the electrification objectives, which remains essential to achieving the continent's carbon neutrality. How do we move forward with the priorities we identified? For this second edition, we turned our ambitions into impactful actions. For what we are here to share our experiences among global DSOs on how to contribute to net zero and set us collectively, on the right path towards their decarbonization. We have indeed the responsibility to seriously evaluate the climate change signals that have become now evident in the past couple of years and get geared to play a decisive role in containing the increase of temperature around the planet, adopting those technologies, adopting the industrial strategies that allow us to consequently deliver on these targets in a long term. But more concretely, first, we had in 2020 and 2021 here in Europe the implementation of the clean energy package for all Europeans. Secondly, since June last year, DSO are finally rightly represented in the EU institutional framework by the so-called E.DSO entity. And thirdly, the Fit for 55 climate package aims to adapt our strategy in the face of the challenge of the century, for instance, with outlining of the gas package, the alternative fuel infrastructure, the energy efficiency directive. All that build up for one common goal, to become the first climate neutral continent by 2050. And you see that DSOs are at the core of this transformation. For the DSOs especially, the creation, I mentioned it, of the EU-DSO entity is a great novelty. E.DSO, with Eurelectric, SEDEC, and Geode teamed up and combined our efforts to establish it. It is now the institutional counterpart of ENTSO-E, the aggregation of the EU TSOs, transmission operators. Now, as equals, we will deliver network codes and provide technical expertise. Such a cooperation framework is key to cater for an adequate framework for the evolution of the grids and their digitalization, and let's say smartization. Rapid and seamless dialogue, concrete dialogue between DSO and TSOs, initiated with determination and personal engagement by many companies, many grid women and guys here, some friends around these events, me included, in the recent past, has already proved the most successful way to pave the evolution of the grids and the relative assurance needed to envisage bold investment plans. During 2021, last year, with the long-lasting, unfortunately, impact of the COVID pandemics, we all had to reassess some investments and plans. The leading DSOs present in this association, in the association I have the honor to chair, E.DSO, have been able to react promptly, to react together. We shared our problems, we shared our solutions, evolving knowledge deriving from the pandemics, and we put in place a strong revision in investment needed, especially to increase connection and the pace we connect of renewables and some operational reshaping. Resilience is about the ability to respond also to cyber and physical threats and to mitigate the consequences of extreme weather events, such only to last year, such as wildfires in Greece. It was dramatical wildfires in Greece, and the floodings dramatically in Germany, in Belgium, annihilating grid infrastructure and hitting hard on the citizen. It also involves all the aspects of digital cybersecurity and robustness of our systems, from grid operation to the financial management and to the management of people on the field, as well as the customer data and history. So it deserves a global approach, a worldwide mutual early alert system, and a shared vigilant mentality and attitude to avoid in all our countries across the continents the risk of harmful blackouts and breaches in the systems. A study conducted by E.DSO, Eurelectric, and Deloitte Monitor showed that in the European DSOs, we European DSOs would need to invest up to 400 billion euro in the next 10 years in order to have a fit-for-purpose infrastructure. Accelerated digitalization, infrastructure modernization, resilience measures, smart meters, full deployment, electric mobility management, innovative storage management, and flexibility management will ask for an increase between 50 and 70% per year of what was till now foreseen globally in Europe in the investment plans. Coming to the current policy discussion in Europe, we appreciate that DSOs have been strongly recognized in the Fit for 55 package as important actors in the energy transition responsible for the integration of renewable and the management of integrated energy system, supporting increasing electrification with customer at its core. Indeed, we must keep in mind the crucial role of DSOs within the new regulatory environment to facilitate the energy transition and to contribute to the EU climate objectives. It is important because we, DSO, are the ones which ensure at the end that all Europeans access a safe, reliable electricity. We are at the end, we are the connectors between the ambition of the Fit for 55 package, the vision of an integrated and decarbonized energy system, and its implementation in Europe, in European cities, in our homes, in cars. We connect policy and concrete implementation to make that decarbonization a reality. You must count on us, our technical knowledge and our experience on the field. We have still 3 policy recommendations for the EU institutions. First, the energy efficiency of electricity distribution grids should be managed in a holistic manner, which places emphasis on the enormous potential of smart grids, smart meters, smart grids, globally speaking, and local system integration. Secondly, the new regulatory framework should mandate EU member states to encourage investments in electricity distribution network or electricity grid, globally speaking, including our friends from the TSO. The aim on the second recommendation is very clear: facilitate the integration of renewable sources while supporting the security and stability of the network. And the third recommendation is a modal shift in transport towards electrical vehicle requires boosting the momentum of the connectivity of the grid, but also in its capacity to sustain the electrification of mobility. These 3 proposals carve a central role for DSOs, which will be tasked with managing a local energy system, a system which relies on energy efficient grids and services, able to integrate clean energy sources and flexibility services, and balances intermittent generation with increasing electrification of the sector, buildings, transport, etc. So along these efforts, sustained by an unprecedented investment, a strong digitalization, and the parallel enhancement of the related cybersecurity aspects is underway. My conclusion: net zero in the carbon footprint, net zero risk in the infrastructures and customer access to the most advanced services stay as 3 of the must-haves on this evolution. And I really hope, I think I can say we together really hope we shall include them in the standards we can all share over the world. Here in Europe, we, the European DSOs, are the backbone of the European energy transition. We will exercise this industrial responsibility in order to leave no continent, not a single country behind. I wish you a very good session and discussion. Looking forward to discovering many good practices among global DSOs today. And as has been mentioned by Roberto, tomorrow morning, a new session devoted to African grids development and expertise will complete the landscape that is becoming truly global. So thank you very much for your participation and commitment in this initiative. Thank you.
Thank you very much, Christian, for your opening keynote. And now I would invite Antonio Camisecra, who is the head of Enel Global Infrastructure and Networks. Antonio will elaborate on combining sustainability and grid development. Antonio, the floor is yours.
Thank you, Roberto. Thank you, Christian, for the invitation. And good morning to all the participants and speakers and attendants. Net zero is the topic of the day, I would say, the topic of the year. And this is with no surprise. In the past years, we have experienced an exponential growth of interest in the topics connected to the global warming, the climate change, the energy transitions, of course. Many events track in the path towards what we can consider a new sustainable model for social economical model for the future. The most recent event has been, of course, the COP26, which marked an unprecedented commitment, global commitment. For the first time after Kyoto, at least as far as I remember, all countries of the globe, most of the countries of participating to the COP26. So let's not be too optimistic. Not all the countries, but most of the, let's say, influencing countries of the globe fixed the deadline for the net zero goals. Most of the countries confirmed their targets. Others had to modify their roadmap, but let's say the key words of the COP26 was actually net zero, which I think it's important, because going behind the Paris Agreement and 1.5 degrees and start discussing about a real, let's say, economical, social economical equilibrium going forward, a permanent, long-lasting equilibrium. It's what I think we have to embrace in the next 20 years. So the keywords after the net zero, I think, is cooperation, because of course now we have a goal quite clear, and it's time to start now working for our commitments. And the question is how. So the net zero ambition is not only related, of course, to energy production, but you have to face the reality. 30 years are basically nothing to solve what is a fundamental problem, probably the biggest global problem we have today. And it's a global one. So the CO2 molecule emitted in our distribution territory, or wherever you are, is exactly having the same effect of a molecule emitted from any other sector in any other country. So this is, of course, a global shared problem. And I think we can only tackle this issue, this problem, if we work together. So let's start off understanding how we can work together in the sector first. So in the electricity sector in particular, and in the distribution sector more. So we need, in my opinion, to connect more. An event like these are, of course, very much welcome, because are in the right direction of sharing experiences, defining common technological pathways in order to make net zero not only a slogan or a target, but a reality. So collaboration within DSOs, among DSOs, is crucial to have let's say, achievable target at the right cost for the final consumers. But of course, this is not enough, because of course we don't work in isolation. Our cooperation must include all the other stakeholders connected to the electricity networks to understand the future needs, their present and future needs, and to coordinate the evolution of our infrastructure accordingly. So if we talk about the energy transition, we have to understand what does it mean in practical terms, so that producers, prosumers, charging point operators, aggregators, and electrifying customers can be included into the equation. So their needs can be as an important part of the planning of the grid expansion, grid evolution, both from a dimensional and technological point of view. And that's not enough, because of course we have to complete, let's say, the setting of the cooperation with the support of institutions, regulators, the standardization committees, who must be available to rediscuss standards and let's say the decisions taken in the past, where the scenario was completely different, adapting the new standards, for example, to the present needs, including sustainability aspects in the standards rule for the technology that we use every day in our grids, removing possibly time-consuming bottlenecks for the authorization processes from in the old, let's say, institutional aspects of our daily life of an operator, from permitting of new projects, or also standardization of a new technology. So bureaucracy, in my opinion, could be the most dangerous enemy of the energy transition, especially if we are having in mind the real net zero target in the next 15 years or so. So once that we have engaged in this broader collaboration platform, I think the next step is planning the strategy. So to win this match, we need to look forward at the goal and not at the present condition. So we need to look with 10 years advance, bringing the 10 years needs today, because we know that the grids are big, very big infrastructure, and crucial for the life of a society. So working with the minimum 10 years view, span of view in front of us, it's crucial. For example, the primary resources like workforces, materials, the new technology, digital or not, that we have to use in the next 10 years in order to reach the net zero goals, must be available every time, every moment, whatever it happens from the economical point of view. No pandemic, no other kind of, let's say, source of distraction, because during the next 10 years, we cannot suffer of, let's say, shortages of any possible resources needed for the net zero goal, which we are experiencing today, as we all know. So to do so, the long-term planning strategy should be performing, sharing our future needs with the supply chain parties. So today we may have an idea what is going to be the grid in 10 years, but if you just go one level down and you talk to suppliers of our sector, there is not the same level of clarity, and the maximum time span in front of them is 2 years, the duration of a contract typically. So stimulating and adapting in alignment with our ambitious targets, also value chain, which is absolutely crucial. So we need innovative solution, sustainable by design, and affordable by everyone. And to do that, we need time. That's why we have to plan it now, so that we have them available when they are needed in the grid. And that's the key concept of what we call the grid futurability, which is, let's say, a new approach of planning the grid in order to prepare our journey towards the net zero target based on this principle. So we have a project. Can you hear me well, by the way? I hope so.
Yes.
Okay, because I noise coming on the back. So grid futurability is, let's say, the global and customer-oriented industrial approach that we in Enel are adopting to identify and prioritize enforcement and expansion in the coming years. So we are planning today what we need to do in 5, 7, up to 10 years of time in every single piece of the grids. Of course, this involves a strategic spread of cutting edge to transform the grids, combining advanced digital solutions to make them more, we participatory, and that's the key word, sustainable, because in order to achieve real sustainability, we need to probably change maybe 50% of the specification of the grids, lowering the carbon footprint of what we use today, substituting many equipments in the future. That's why before I was talking of standardization. So we have to include sustainability aspects in the grid today, so we can start lowering the carbon footprint of our technology going forward. So we have to prepare the grid for the future, for a complete decarbonized and electrified world, being our carbonized as much as we can, in order to offer the best quality of service to the customer, but also to be in tune with the ambition of the entire society to become more lean, more decarbonized, affordable, considering also that we will have to use technology suitable for low spending power countries, where the same ambitions, the same targets, the same needs of decarbonization will be present, because the problem, as we said, is global. So we have to help by developing technology that can be used also in emerging countries or converging countries, as much as we will use them in advanced economies. So to reach our net zero goals, sustainability, again, must be at the core of the future business. For this reason, we started integrating new principles, new sustainability principles in all our processes, but most importantly, this is an entire new chapter for the engineering of the grid. So we use the typical engineering and economical to define a new technology or to define an engineering standard. Now we have an entire new chapter, design principles, which is related to sustainability. So if a solution is not sustainable, it's not in line with the net zero ambitions, we cannot define or use or design that specific engineering solution. So we're starting today because probably you know Enel has anticipated to 2040. So with 10 years advance, with a general global commitment that taken into the COP26. So we want to be net zero as a company by 2040. So we don't have that much time in front of us because, as we said, the grid is wide. Our grid is immense. We are one of the biggest operations globally. So if we want to be ready by 2040, we feel the sense of urgency already today. So to be clear, we are working with an holistic approach on all the three sectors, scope 1, scope 2, and scope 3 of emissions. So the direct, indirect, and related. A few examples. Scope 1, we know perfectly that in our business we use the sulfur hexafluoride emissions because we use as an insulating gas in many equipment. So the SF6, which, just to give you some figures, globally emits, let's say, has the same effect, the same greenhouse effect of about 100 million cars emitting CO2. So it's a, sizable, visible impact. Not the biggest one, of course, but it's for sure one that is quite visible if considered globally. It is used in about 30 million units of switch gears worldwide, which installations in the next years is supposed to increase. So we have to ban SF6 from now. There are alternatives, yes. We know that perfectly that we are responsible, we as an energy industry are responsible for more than 80% of the emissions of SF6 in the atmosphere. So we are working not in isolation. I will explain in a moment why, to find alternatives to the SF6 to be substituted with the other gas mixtures. This is possible. And it will be even more possible if we work together, because of course our isolators, our switch gears are not different from the ones that are used by our peers, our colleagues. So working together, it's crucial in order to don't pay a premium for a sustainable solution, which is, I think, the key aspects of going forward. So we have to use sustainable solution at the cost of possibly even cheaper than the solution that we use today. And we can do that if we transform quickly what is an innovation into a standard, widely used technology. And to do that, we have decided to open up in a pure approach our specifications. So in a few days, there will be a portal where every manufacturer, every developer, every competitor, let's say every peer, distribution operator can go and draw down, let's say, download the engineering specification of Enel, just as a matter of comparison of stimulation. If you want to check what we're doing in order to try to converge into global common specification to reduce the effort of the manufacturer to converge quickly towards the sustainability that we're talking now. Other example, we want to substitute the corporate light duty and heavy duty vehicles for the operation on the grid. Today, for certain uses, not in all countries are available pure electric vehicle. Think, for example, the movable cranes or stuff like that. Typically, they are not electric, but we are now defining the use cases and talking to the equipment manufacturer in order to convince them to start producing those equipment quickly, much quicker than, much early on than their actual marketing schedule. And my consideration here is that if we could do this together, we would have a market power much stronger in order to convince a car manufacturer or a truck manufacturer or secondary, let's say, truck installators to work with us faster, because that's another source of emissions that we have to tackle. On scope 2, of course, it's about the reduction of the technical losses of electricity. This is about 45% of our total emissions. It's about 3.6 million of CO2 equivalent tons. And by working well with digitalization, measuring exactly in which point of the grid you are you are, let's say, wasting energy in the grid, still a huge space for improvement is possible. So we plan that with our ambition reduction target, we can save more than 13,000 gigawatt hours by 2030, which is the equivalent of many new renewable plants, just to give you an example. So the measuring, studying, defining a solution and implementing them is possible in order to drastically reduce the technical losses in the grids, even in the most advanced ones like the one we have in Europe. Finally, the scope 3. Scope 3 is what the one are the, let's say, the supply chain. So working with the procurement supply chain for new components and devices, as we said before, it's crucial. So we have to start pressing and pushing our supply chain in order to start this journey together with us. So opening our specification publicly, it's absolutely, I think, a crucial part of things to do in order to converge to common solutions, to make them cost less. Again, I said it again because I think it's very important. Using recycled material and not only thinking of recyclable. I would rephrase this again. Introducing recycled immediately now, and not just ask of having recyclable materials at the end of the life of our grid, because we have to start contributing to reduce the carbon footprint today. For an example, our digital meters, our smart meters, are today made for 54% of the total weight of recycled plastic coming from the old. And we will reach more by absorbing plastic coming from other things. And the goal is, of course, in very few years, but very few, I mean, by within 2025, to have a completely recycled and, of course, recyclable digital meter. So the digital meter will be completely circular from 2025. So we can keep going by biodegradable alternatives, or for insulation oils or transformers and so on. So, but this will be quite boring. Working together with supply chain in order to start pressing the supply chain to innovate and introduce more sustainable technologies. I will conclude by saying that we don't want to keep this only for us, and indeed we are the grid futurability approach has been put at the center of the idea of incorporating the grid expertise company, which is a company that we have formed and launched in 2021. Allocating in grid expertise our more than 20 years experience in the digitalization and the digital solution for grids, not only on the smart meters, but on the entire, let's say, spectrum of technologies that in a modern grid are used. So grid expertise is now a commercial company that, again, leveraging on the 20 years experience of Enel, is offering digital solutions to any DSO operator around the world, with the goal of helping grid operators to lead the digital journey that we started many years ago, for which we, as I said, in the pure spirit of us considering this global problem, let's say, solvable only with global common solutions, grid expertise is on the market in order to help any grid operator that want to speed up in the digital journey. Because there is one thing that we have understood, one lesson learned that is coming quite clear to us. Digitalize the grid is important in order to go towards the energy transition for the complexity, the flexibility, the presence of new actors in the grid, but also to try to resist more infrastructure while we will cope with the hardening of the weather phenomenon that unfortunately the climate change is presenting to us. And the digitalization is a fantastic tool to do more with the existing assets. So that's extraordinarily important also for emerging economies where probably the financiability and the spending power of consumers will not allow easily massive investment programs in the next years. So to conclude, in the next years, we will face some pressure on us. We know it. We will need to invest to prepare the grids for the energy transition. But this transformation must be conducted in a very sustainable way, which I think is not a problem. It's not a limit. Actually, it's an opportunity because we can introduce new material, new technologies, new circular processes. Meanwhile, we will renovate the grids, which we'll have to do anyhow because we have to prepare for the energy transition and to resist to the hardening of the weather all around the world. And this will give us the occasion to reduce the carbon footprint, so to be more ready or completely ready for our shared. That's my vision.
Antonio, are you done?
Yes, I said, yeah, I said that were my last word.
Okay. Okay, because it was not so clear. Thank you very much for this insightful, although a little bit longer than the amount of 10 minutes that you were awarded. But we have been lucky because our third keynote, unfortunately, had the problems in landing and cannot join the in timing of its landing and cannot join the session.
I filled your space. I filled your empty.
So thank you very much for this. A lot of interesting prospects in terms of technical specification sharing is quite important. And I think that this will be discussed longer in the way. Christian, do you have a consideration here?
No, just to thank Antonio. Yes, was very interesting for all of us. Thank you, Antonio.
So thank you very much, Antonio. You triggered certainly a lot of questions to come. There was already one, if this is working also on higher voltages, and let's say 400 kilovolt, for instance. But I think that we can address that later during the debate. And this was coming from Ronnie Bellman's emeritus professor at Leuven electric engineering faculty. And we shall address it, or you can have it address it directly to Ronnie through your assistants. Thank you very much again. And now let me go to the panel that is going to have reactions on the keynotes here. So may I ask Mr. Osei Ikeda, Chief Engineer of Tokyo Electric Power Grid, to come on the screen and give us these considerations on the keynotes and on the notion of the platform. Please, Mr. Ikeda.
Can you hear me?
Yes.
Okay. Thank you for your introduction. I am Osei from TEPCO, Tokyo Electric Power Company, Power Grid. And I apologize for my face mask to be on because I'm at the office. I cannot take him off. I'm sorry about that.
What?
And about the reaction, I thought I sent PowerPoint slides. And I thought I would be talk about. Yeah. Okay. Thank you. What I do in my company is R&D for advancing distribution power grids. And talking about a net zero, there's a lot of photovoltaics also in Japan. They're so increasing more and more. And by the increase of the beyond estimation, we are struggling with applying interconnections, controlling voltage on grids, making plans for grid reinforcement, and et cetera, et cetera. There's a lot of struggling problems. But One of the major problems we are facing is flickering that are caused by photovoltaics. And actually, it's a photovoltaics, but it was due to the reactive power by the PCS as a conclusion. And would you start playing a video? If you click on the picture, I think the video will start playing. Yeah, I'm not sure if you can see the video very well, but the video shows when the flickering happens and the light becomes like bright and dim consequently. And that happens because of a lot of photovoltaics are introduced to the grid. And at the area of occurrence, the flickering, the motors and the delicate instruments, such as MRIs in hospitals, have stopped their operation when the flicker happens. And these flickers are triggered a lot of complaints that needs to be dealt with. And we are struggling with that also. And for example, there were more than 200 complaints from flickering area in one day. So we worked on elucidating the cause and the countermeasures. Just show the next slide, please. Okay. So we figured out that the isolation detection function in the PCS is the cause of the flickering. And this isolated detection function is a really long name, but it's been required by the grid interconnection code to prevent the isolated operation. Like when there's a fire on the building, before the firefighters shoot their waters, we need to stop the electricity supplies. But if the isolated detection is not functioning well, the photovoltaics could just keep supplying the electricity, and that could lead to electric shock. So the isolation detection must be introduced to the PCSs in Japan. The code, the grid interconnection code, doesn't actually designate the method to detect the isolation, but the recent method that is applied is enhances the frequency deviation by the reactive power, and it is used because it has good certainty and quickness of detecting isolation. And it's supposed not to affect frequency a lot when it is not isolated, but when a large amount of PCS synchronizes their output, the reactive power output combined becomes so large. Although it may not consider as isolation, it may affect frequency enough, and that becomes a flicker. Could you show the next slide, please? Thank you. Prevent flickering from happening, we are taking two countermeasures. The radical measure would be to introduce a PCS with modified specification to descend the reactive power output as much as possible while ensuring that isolation could be detected for sure. However, it takes a lot of time and effort to modify all the existing PCSs. So we are introducing StatCom as a immediate measure. The StatCom offsets an excessive Q deviation from PCS, which is expected to suppress the flickering from happening. So that will be all for sharing what's happening in Japan, the flickering caused by the photovoltaics. Thank you for listening. That would be all.
Thank you. You have been extremely brief, but very, very much interesting, Keda-san. and I would like you to stay on for the Q&A at the end of the reaction from the panelists. May I now ask Mr. Ganesh Srinivasan, CEO of Tata Power Daily Distribution, to take the floor and offer us the perspective from India. Please, Mr. Srinivasan.
Thank you, Roberto, and thank you to EPRI, Eurelectric, and E.DSO for giving this opportunity to share the Indian perspective. So I'll share a few thoughts, a few slides on where we see how we can achieve net zero from an Indian perspective. So if you can go to the next slide, please. Yeah. So what is India's commitment that has been made in the recent COP26? So India has made a commitment to reach net zero by 2070. That's of course about 48 years from today. Seems like a lot of time, but is quite challenging. As Antonio rightly said, it takes some time for the planning, and I'll share a little bit more about the challenges that we need to overcome in this period. But more importantly, I would like to highlight the second bullet, which is India will meet 50% of its energy requirement from renewable energy by 2030. So that's actually a tough task, given that we are in 2022, so 8 years, but and approximately about 25% of our energy comes from green or renewable sources. So taking that 25% to 50%, and knowing that India is growing at 5 to 6% per annum as far as energy requirement year on year. So that's quite an important aspect that we need to consider. As Tata Power in India, we have taken a pledge to be carbon neutral or net zero by 2050. That is almost 20 years ahead of the national deadline. If you go to the next slide, please. Just wanted to give a quick glimpse of us as Tata Power, who we are. We are a joint venture between Tata Group and the government of Delhi, the capital. And we have been at the forefront of implementation of multiple technologies for the last 20 years. And because of that, in the recent Smart Grid Index benchmarking, which was done by the Singapore Power Group, we were the top Indian utility, and very, very glad that we were among the top 20 global utilities. So we still have some room to improve, but it was very heartening to see Singapore Power peg us in the top 20 utilities globally. We have about 1.8 million customers, almost 2,000 or 2 gigawatt of peak load, a relatively small rooftop capacity today at 42 megawatt. Similar to the national average, our clean energy, which I would say is both renewable and hydro put together, comes at about 25%. Our carbon emission, specific carbon emission, is about 0.66 million ton per megawatt hour. And we have done quite a bit of technology, but just two that I wanted to highlight is that we have a storage capacity. We have a 10 megawatt battery energy storage system, which is there in our distribution license area. And we have about 0.25 million of our customers that have smart meters. So just one more piece of context for the global audience, that in India, we don't have a separation of network and supply. We as a distribution company manage both the network as well as the supply aspect. So we play the dual role of both the network operator as well as the supply licensing. You can go to the next slide, where I'll talk a little bit about the challenges that we see. This is of course at a macro level, at a distribution company level. One of the main challenges is the thermal power purchase agreements, or the thermal tie-ups that we have. These are what we call in the regulatory parlance here long-term power purchase agreements, which go up to almost up to financial year 2040. So almost, I would say, 18 years of thermal power-based capacity which will remain, and that's a challenge, of course, that we have to we can't exit these contracts because these are long-term contracts that have been signed. And associated with that is the fact that these thermal power plants have to run at a technical minimum of 55% based on the technology that is installed. So even if I grow the renewable capacity more, there is a limit beyond which I start having excess power in the system, or I have to dump that power in the power exchange and get very little realization for that, because the thermal power plants have to operate at 55%. If, of course, I know that the demand is not there at all for the next 10 days, a week plus, then I can shut down the plant. But since I don't have any sources of power for the night, I have to keep these running, and that is a major challenge. We also have very stringent deviation penalty mechanisms to control the frequency of the grid. And this is, of course, very, very important for grid security. But coupled with the fourth challenge, which is the infirm nature of renewables, we have done an analysis that solar schedules that are given by the solar generators and the wind schedules that are given by the wind generators, as compared to the schedule that is given versus what actually we get at that time slot, there is almost a 40 to 60% variation in what is planned versus what eventually the power that we get. So this poses a great challenge for us as a distribution entity to manage our deviation within the limits that are prescribed by our regulator. Some operational challenges, of course, India as a country does not have much hydro or nuclear. So that's why coal and gas power stations have to run, and there's a need for us to have alternatives to base load if we have to achieve net zero. So the economical storage solutions become very critical, as well as how do we manage the distributed energy influx of electric vehicles. I think my colleague from TEPCO just spoke about the voltage variation, so the increase of PV, and of course smaller scale storage and how it can manage the DER. If I can go to the next slide, please. So these are some of the challenges and uncertainties. What are we doing about it? I wouldn't claim that we have a perfect answer right now, but we are working on multiple things that will help us get there. The first one, these are some of the example projects that we are doing. These are all technology projects, many with, of course, regulatory aspects as well. We are doing a project called E.Electrics. This is basically demonstrating the solar energy storage, LV automation, as well as islanding aspect. We're working with Enedis, Schneider, Audit, GECO. So this is a very prestigious project funded by the EU, and this will help us demonstrate an urban island and how we can manage the grid in case of a failure from the grid side. And that is a very important demonstration project that we're doing. The second deals with planning. So as we all know, we do network planning on an ongoing basis, but network planning of the previous era versus what is required in the future with influx of rooftop solar needs a whole lot of rethink. And this is one aspect that in this project that has been funded by the Government of India as well as Canada, we are working with Opus One, Ryerson University, which is based out of Canada, as well as BLP, which is an Indian company, on how do we plan the network when we know that solar is going to come in, and what are this is how do we do it on a real-time basis. The third is peer-to-peer exchange between a consumer and a prosumer. Those who have excess solar, future can have battery storage also tacked on to this. So that's an area of work that we are doing along with Power Ledger, which is based in Australia. And lastly, we are working with AutoGrid, which is for behavioral demand response through our smart meter program. So these are some of the technological interventions which will play a critical role as we approach or we work towards net zero. If you go to the next slide, please. Yeah, some of the storage aspects, I think since we don't have much nuclear or hydro, grid scale storage will play a very critical part. If once the thermal phases out, we need battery storage or storage of some kind to actually play a very big role in the firm power. And we have a 10 megawatt battery storage system that we have, which has been kindly installed by Mitsubishi and AES. This is something that's a demonstration project that we are working on from an economics perspective. Very important aspect is the amount of cooling load that the batteries take and how it can be optimized for the Indian weather. So these are some of the technology localizations that are important if India has to achieve net zero. Similarly, we have a kilowatt scale project which has been set up by Leclanche and Exide, which is the Indian storage company, at a transformer level. And of course, we are also working on a pole level storage as well. And working with GIZ and Fraunhofer on how we can actually marry green mobility and smart charging as EV network really grows in the future. Can you go to the next slide, please? So this is the last slide. And where do we see the roadmap going ahead? Yeah, so I'll very quick. So these are some of the technology collaborations that we have. We think it has to play a very critical role. As Antonio rightly said, more sharing and more comparison. And I was very glad to note that the specifications of NL will be available in public domain, which will really help utilities like Tata Power to compare ourselves with what are the specifications that are being used and how do we actually take it forward from there. If you go to the next slide, please. Yeah, this is the last slide. So where do we see the path to net zero? We aspire to grow our green power to 50% by 2030. This will require an aggressive growth of our renewable capacity. Somewhere around post 2025 or so, we see storage coming into the grid as well in a larger scale. Most of our coal-based power plants will get phased out by 2040. So we need to use the next 15 years or so to prepare for that reality. As of now, not all it's still hazy as to how the life will work out at that time, but it's very big energy transformation that we have to get prepared for that. Green hydrogen, we believe it will play a big part. We're doing some projects on that. Still, cost is a big aspect right now, but that's an area that we are working on. Distributed energy, I think we spoke about that. Resource optimization and energy efficient products. I think one area that SF6 being one of them, but also how much copper does a transformer use? How do we actually optimize on the footprint of the network itself, not just the power, but also in everything that we do as a distribution company? How can we bring sustainability into the picture? And lastly, we believe that behind the meter storage will play a very critical role, at least in India, because as nighttime power is really not very easily available which is a replacement for coal. We believe that nighttime power will be very important aspect, and here behind the meter applications, both by the customer as well as storage applications by the distribution company, both have to work in tandem. It will be economical for customers to put behind the meter storage, and that will scale up quite a bit. So that's those are some of the thoughts. As I said, these are work in process, but we believe that these are the right things to work on, and we welcome this forum for enabling us to share and taking it forward. Thank you very much. That's it from our side.
Most welcome, and thank you very much for this very detailed insight from the top Indian operator, Mr. Srinivasan, and it is very refreshing to be really on a let's say parity level with the debate of the other DSOs everywhere in the world, because we are all focusing on the same matter, and your vision of having it seen in a reality like yours has been extremely inspiring. I think that you will have a couple of questions during the debate, if you may stay on. I do thank you very much, and now ask on the screen Mr. Dr. Changung Shin, Head of Distribution Lab at KEPCO. Dr. Chang, you have the floor. Dr. Chang? Any problem? He's connected. Hear me? He has got. Now, yes, Dr. Chang. Okay. Please, you can come also on the screen, There you are. Thank you very much. You are welcome. And please, we are looking forward to listen to your presentation. Please.
Okay, thank you, Roberto. Nice to meet you, everyone. I am Chang Hun-shin, directing Distribution Laboratory of KEPCO Research Institute. Today, I'm going to talk about carbon neutrality policy in Korea and DSO demonstration plan of KEPCO to support it. Next slide, please. And next slide. Yes. Korean Carbon Neutrality Act was established in September 2011. The government set a national vision to achieve carbon neutrality until 2050 and will promote the harmonious development of the environment and economy. It has to cut emissions 40% from the level of 2018 until 2030. This goal is very challenging in comparison with other OECD countries. Energy sector, which occupies 45% of the total emission, has to play a key role in achieving net zero emissions. In generation sector, the policy includes the suspension of coal power generation and a significant increase in the weight of renewable generation. In the energy consumption sector, we should focus on electrification and energy efficiency. More than 97% of vehicles will be battery-based or hydrogen-powered electric vehicles. When it comes to the T&D sector, the grid requires significant changes on network infrastructure, system operation, and market design. To maintain stability with highly hosting distributed energy resources, diverse technologies should be developed and demonstrated. For example, matching demand and supply in terms of time and location, new capacity enhancement, intelligent flexibility operation, and new energy market. Next slide. The numbers and capacity of distributed energy resources into the distribution grid require utilities to play an important role in enhancing DER hosting capacity and actively managing the DER to mitigate the system uncertainty and unbalance. To back up the Carbon Neutrality Act of government, Distributed Energy Activation Act was proposed in July 2021. It provides the legal foundation of the distribution system operator, DSO, as the authorities' integration and curtailment of DER was expressed for managing system stability. And as responsibilities, keeping grid neutrality and taking regulatory audit was imposed. It also suggests the regulation-free zone for promoting the demonstration and evaluation of the future grid, market, and business models. KEPCO, as the initial DSO, is developing its capability step by step. Currently, KEPCO is preparing the phase 2 of DSO for integrating flexibility support through DER management and heading for phase 3 for active management of DER through the market-based operation. Next slide, please. Next, KEPCO plans to demonstrate phase 2 of DSO in Jeju Island. It is located on the southern part of the Korean peninsula and seeking a carbon-free island by 2030. It has already a considerable amount of renewable energies in the grid and so had experienced frequent curtailment due to the excessive generation. Total 77 times and 19 gigawatt hour of curtailment already happened in 2020. So KEPCO considers this island is the perfect place for experimenting with the various operation scheme and market rules. From this year to 2024, KEPCO will participate as a DSO in a governmental joint demonstration project with KPX, E.DSO of Korea, virtual power plant aggregators, and DR providers. KEPCO will deploy the advanced distribution management system for the integrated operation of DER in the distribution network. It is to experiment hosting capacity analysis and controllable flexibility or DERs. The cooperative operation of TSO, DSO, and VPP aggregators will be prepared, and new market rules will be evaluated in terms of aggregation of DERs, vehicle to grid, plus DR, and power to heat for minimizing renewable curtailment. Next slide, please. But there are several issues to be addressed. Roles and responsibilities between related entities on DR curtailment should be clearly defined. Flexible grid operation to mitigate curtailment of utility-owned or market-participating DRs has to be considered. Also, each DL is bidding for the power market of KPX, its TSO. Most of these resources are connected in the distribution network. So effect of DR in the distribution network has to be evaluated in advance. In addition, IT system architecture should be considered for satisfying cybersecurity requirements, and cost-effective monitoring and control infrastructure has to be considered. Next slide, please. Yes, next slide, please. I'm going to summarize my intervention. Korean government finalized the 2050 carbon neutral scenario and NDC target for 2030, which is 40% reduction from the 2018 level. Energy sector plays a vital role in reduction. Distributed Energy Activation Act establishes the legal foundation of the distribution system operator for national ledger vision. Demonstration project for DSO and integration of DRs will be launched in Jeju Island this year. Jeju Island will be designated for the regulation-free zone for distributed energy activation. Future grid operation, new market rules, and related system will be demonstrated, and a new business model will be evaluated. Yes, this is the end. Thank you.
Thank you very much, Dr. Chang-Gu Shin, and extremely interesting the project to lift completely regulation in an island in order to develop new business models. And it will be interesting. You're invited to the third edition already to report on the outcome of this experiment. This is the evolution probably of what here in Europe we are accustomed to call sandboxes. So just experimental new framework for regulation. But you here speak of totally lifting the regulation in one island. And this is extremely interesting for the future of the market design. We shall address this maybe better during the debate. I do thank you for the moment, and would like to call on the screen, if possible, Mr. Yu Wei Shang, Senior Engineer and Deputy Director of Intelligent Operation and Maintenance Technology Research Department of the Center of Power Distribution Technology of China, and of the China Electric Power Research Institute. So the Chinese cousin of one of our partners here, EPRI. So Mr. Yu Wei Shang, you are free to come on the screen and bring your experience in the view of a senior engineer and the deputy director of such an important research institute. Please, you have the floor.
Thank you, Roberto. Can you hear me?
Yes, very well.
Okay. Nice to meet you, everyone. I'm Yu Wei Shang from China Electric Power Research Institute. It's my honor to share with you the consideration of technical challenges for DSO's operation management in China. Before I move to the main parts, I think I'd like to give you a short introduction of the electric power distribution system of State Grid Corporation of China, in short, SGCC. Please, next slide. In order to set a little bit of background for everyone, driven by the net zero ambition, distribution systems has been seen as a central platform for urban-rural green energy transformation. And after years of development, some progresses have been achieved for improving the power supply capability, reliability, efficiency, service quality, access capability for DRs. And currently, my colleagues and I are working towards the establishment of an innovative energy internet, where we expect our distribution system to be safe and efficient, greener and intelligent, more reliable and resilient, and flexible and mutually beneficial. The figure in this slide shows some scale of the distribution assets in SGCC. And with such a level of our system, we actually have a lot of challenges to meet in the late future. And I believe some of the experts have mentioned from different perspectives. But in the next few slides, I will mainly focus on the operation management perspective. Next slide, please. First, let's take a look at the table as shown in the left side of this slide. In the entire power system, we can see compared to conventional power stations, gradually wind and solar energy is estimated to become the main power supply in China. The proportion of installed capacity will exceed 60%, and their proportion of electricity generation will exceed 55%. And the application patterns of wind and solar energy is mainly about centralized and decentralized application patterns. And in the distribution system sector, now we can see in a lot of areas in China, like rooftop PVs, centralized and locally decentralized PVs, macro PV stations in many places. Especially last year, the National Energy Administration issued to develop PVs by county, and over 600 counties were approved. So as this action plan went on, by the end of 2025, the total installed distributed PV generators is estimated to reach 108 million kilowatts with an increase of 200%. So as abundant customer-set devices are connecting to our system, which will fundamentally change the one-way definite closed-form system architecture and greatly increases the complexity and difficulty of system operation management. Like one of my colleagues said, we have so much work to do, but in such a short of time, especially for system planning, operation, and asset management. Next slide, please. So for system planning, traditionally of system planning is mainly focused on electricity, but with large-scale DERs access and multiple stakeholders, we believe the system planning requires a new model, that is the electric carbon coupling model, which means we have to see our grid not only from the electric part, but also from a carbon reduction perspective. So in the planning objectives, besides traditional technical and economic objectives, we have to put more attention on market factors such as green electricity trading and sustainability targets such as system security, including cybersecurity, resilience, especially for extreme conditions, and our asset efficiency. And because we have regional differences all over China, actually we have to take multiple factors into consideration, which makes our planning model is even more complex. And when we making the planning into reality, we have different options to realize them. If we tackle these options one by one, we have low planning efficiency in reality. So currently we are working towards models and tools for multi-scenario and multi-objective probabilistic planning tools. We believe this is a technique and tool for the future planning work. Next slide, please. For power dispatching and control, the biggest issue is about uncertainty introduced by DERs. And when we integrate such large-scale DGs into our system, it requires us to have wide area distributed dispatch and control capability. Like the previous slide, nowadays many PVs are installed in rural areas, but the observability, controllability, and resilience of these areas, the systems in these areas, are still insufficient, especially with weak information interaction between the utilities and customers, which hardly meet the demands of maximum local consumption and intelligent management of DERs. Similarly, when we thinking this issue, we have abundant scenarios with complex composition, different elements such as wind and solar energy, electric vehicle charging piles, grid-connected microgrids, battery energy storage systems. All of them have to deal with the strong uncertainty. And we have different means to control them, from customer interfaced devices and grid equipment. But when we put all of them together, it's very difficult to coordinate them. And the most urgent need is the model and tools for system spatial temporal coordination in different areas, different levels and scales. Next, please. Next slide. And for system maintenance and asset management, the biggest challenge is about the complex of operation modes. DRs connected to our system leads to a surge in the number of points of common coupling, which increases safety risks, complexity of network operation topology, and the costs for system maintenance and asset management, because we have limited resources and labors for doing such kind of tasks. But traditional maintenance strategy mainly focuses on historical indicators, such as improving the reliability indices, which actually limits the accuracy of equipment health condition assessment and the optimality of system maintenance strategy. Because we have now more complex failure mechanisms, both from the grid equipment such as distribution transformers, circuit breakers, cables and overhead lines, and also in the customer interface devices, particularly the power electronics equipment. So from the system level, we have an increase of risks of fault. So we are now developing a system level health management model and tools to tackle this challenge. What we are trying to do is to efficiently and accurately evaluate our assets' operation conditions, which provides early fault warning capability to which leads to a lean life cycle management and improvement of our assets' performance. Okay, it has been my pleasure to give you some of the viewpoints on system planning, operation, and maintenance. Thanks again for your listening.
Thank you very much for your contribution, Mr. Shang. And I think that we could now start a debate among us. We are a little bit ahead of time, and please thank you very much for having kept the time on your presentations in general. So we have got quite a series of questions in the chat and in the Q&A over the discussions, but we think that we could start also from a couple of points that have arisen also interest in our chat. And the question for all of you, asking for a brief answer if you can, and it is about the business model for distribution companies. Do you think it is going to change this distribution model for this distribution model over the next few years radically, or start a change in the next few years also in the footprints of what we heard from Korea, this concept of DSO 2.0 and the experimentation of new regulatory boundaries, to say. What are the plans in your own company to address possible business model changes? It could be interesting. May I ask all the panelists to come to the screen and probably give an answer if possible?
Can I, Roberto, can I share a few points on this?
Yes, absolutely.
Yeah. So I think it's quite it's not a question of whether it's going to change. Of course, I think it's the quantum or the scale of change which is more important for us. Definitely, we have at least I can talk from an Indian context that distribution or the distribution supply has been fairly, I would say, linear. One can say, and with rooftop, with solar, with other aspects that are coming in, definitely there is huge change that is expected or is already that we see. As a company, we have been working on regulatory sandbox experiments with the support of our regulator. For example, the peer-to-peer work that I just spoke about, that regulation does not exist right now, but we have carved out for a few months in the year for some quantum of customers. We have worked with our regulator to ensure that we can run that pilot so that we understand how customers behave or whether they will participate in such a pilot. What are the benefits like for the distribution company? What are the benefits to the prosumer consumer? So I think the biggest role is for us to create these regulatory sandboxes like the one that was shared by KEPCO on the DSO 2.0 in an island. Such regulatory sandboxes have a very critical role for us to understand and then scale it up in the larger distribution context. Thank you.
Thank you very much, Mr. Srinivasan. And any other comments from the other participants on the figure of DSO 0.2 and what is the reaction to a new possible business model? Maybe Mr. Shin Chang-hoon, you have triggered very much of an interest here about the possible expectation from the experiment of a new model. So what do you expect in your company to come out from that? If without going too much in confidential reasoning of your company, of course.
Okay. Korea has a challenging declare of carbon neutrality, and our company KEPCO is planned to demonstrating DSO as a starting point. This condition is just monitoring and watching the DERs in our grid. The next stage, through the demonstration, we are to control renewable energy to mitigate to accept our power grid stability. And Jeju Island is a much deeper, high penetration of renewable energy. So this example is could be applied our mainland renewable stage. So this demonstration project is very important for KEPCO. So we are discussing a lot of entities in Korea, but we are deeply to we need some other countries example and experience will be keenly needed. Okay.
So thank you very much. Thank you very much for these. Now I would like to put some specific question, and then I will come back to you anyway. And because well, there it is. Because as many times it happens, I did close the chat and I did not find exactly the questions I wanted to put to you. I've got a first question. It was put during your intervention, and it is for Ikeda-san. As the penetration of energy storage becomes broader, especially distribution and customers, will that eliminate the need for STATCOMs? This is a question from Mark from Granigan.
Thank you, Mark, for the question. And I believe that the power storage can suppress the flicker from happening. If the power storage would have a function to suppress the delta Qs, the Q output, reactive power output from the photovoltaics PCSs. But especially for the power storage by the customers, it's hard to think that the power storage would have such a function to offset the reactive power deviations for the DSOs. So I'm afraid that we need a STATCOM until most of the PCSs are replaced to a new PCS that are modified to have less reactive power outputs. Would that be good for the answers?
I think so. Maybe Mark, if you need the details, please put it in the chat, in the open chat. And I have got also a question for Tata, for Tata's CEO. So it is your E.Electrics project is a very interesting one. Is an evaluation of the economics of urban islands as a part of overall resilience strategy also part of the project? So within your project, do you also evaluate the economics of urban islands?
So I did type that response out in the chat, Roberto, later.
Yeah.
Yes, to some extent, I would say that the initial focus is more on the technical and feasibility aspects, and particularly the economic challenge is more from the actually the cost of solar is quite substantially low now, and it is not much of a challenge, particularly in the last, I would say, 10 years. India has seen a dramatic reduction in, I'm sure it's the same situation across the world. India has seen a dramatic reduction in solar cost, but storage is still a very different ballgame, and we are not yet able to fully justify economically the cost of storage getting integrated into the grid. We are very hopeful that the situation, as has been seen in solar, we will see a similar cost reduction in storage as well. But that point is, we have not reached that point. So yes, we have an eye on the economics, but there is still a lot of cost or economic reduction in cost that is required for it to be comparable to the alternatives of grid supply available. Of course, from an islanding perspective, there is no comparison because islanding is in a scenario where there is no other power available. So any power at that time at any cost is cost effective. But for us, it's also important that we are able to prove it at a reasonable cost as compared to the alternatives. So storage cost still remains as a major challenge for us, net.
Yeah, I have seen your answer on the chat, but I wanted you to repeat it for the sake of those that are not following the chat. And staying on India, you had another question for you, and it seems like India could be a world leader in developing an economic strategy for local energy storage and PV to be a real part of resiliency solution. Do you think this is applicable to your strategy?
I would say that there are two parts to this. I think India rooftop, especially if you look at where the large energy consumption is, which is in the cities, there is hardly any roof space available. It is unlike, say, in Australia or other parts where there is plenty of roof space available. In India, in the urban cities, whether it is Mumbai, Delhi, Bangalore, any of the large cities, very little roof space available. So local generation will be there, but in India, what I feel is the grid generation at the grid scale and then wheeling that power through the transmission network to the distribution entity, that will be the larger quantum. Rooftop will scale up, but not as much as the grid scale energy, which is coming from outside. So that would be my take, sir.
Very good. I have two questions that are not coming on the chat for Yue Shang, Mr. Shang. The first question is, in the future, what is, in your opinion, the blueprint of the State Grid Corporation of China in building the energy internet? So I repeat it, in the future, what is the blueprint of the State Grid Corporation of China in building the energy internet?
Okay, that actually brings a very big question for me. And from the well, first I think I will start by the research and development sector of this problem. And actually, we have we are moving from the ultra high voltage level along to the low voltage level. In all of these areas, we are studying about system dynamics, protection and control from all these voltage levels, marketing, carbon reduction mechanisms, and the integration of other distributed or centralized energy resources, because we have different application patterns when we apply different sources into our grids. So all of these researches are conducted by different researchers in China. And besides research, we have also developed some demonstration projects in different parts of China, such as in Sichuan province. We have very rich of we have many rivers in that area. So that is one way of interconnecting renewable energy-based generator with our power system. And in Xinjiang province, we have very rich solar energy. And in the east part of China, we have many industries, industry parks where we can install rooftop PVs in these areas. So all of these different patterns, we are taking a lot of experiments on these application patterns to see. And I think finally, there will be a combination of all of them into our system, which will make our system be like an energy internet. And of course, the digitalization is one of the important part of this system, including Internet of Things, cyber physical system integration, cyber security, and we also launching a new program that address the cybersecurity because the traditional cybersecurity is closed form. We are now handling an open form system architecture, which means we have to deal with more interactions between our system and the customers, or we call prosumers. So the closed form cybersecurity techniques cannot fully support such an architecture. So we are implementing some techniques such as zero trust cybersecurity technology into our system to enhance our cybersecurity levels. So all of different aspects of technology and demonstration projects are going on to move us into an innovative energy internet in the future. Roberto.
Very interesting. Very interesting, Yue. The notion of zero trust should be immediately transferred in Europe, where we have just started the proceedings to reach a cybersecurity network code shared between DSOs and TSOs. It does not sound fascinating, but zero trust is a real prudential way to put it. And thank you very much for that. I think I will borrow this expression from you. I have got in the chat another question for you that you probably have already seen, and it is does China Research Institute see a penetration of power electronics switchgear as part of automation strategy at distribution level? And Mark was noting that there are 5.8 million distribution switches in China.
Thanks, Mark's question. My answer is yes. And I'd like to give you an example on this issue. Like the data I presented in my slides. So nowadays, many distributed generators such as PVs are installed in villages, mostly rooftop PVs. Let's say if in one place there is a distribution transformer, the installed capacity of rooftop PVs exceed the capacity of this distribution transformer. Traditionally, we have to replace this transformer as we interconnect all of the PVs in this place. But if there is an adjacent distribution transformer, we can use power electronics switchgears to interconnect these two distribution transformers. I see their low voltage ports. together to use the spare capacity of another distribution transformer. In this way, we can save the cost for replacing the distribution transformer and make these two distribution transformers at a more economic level of utilization. And currently, we are actually launching different pilot projects in the east, middle part, and the west of China. The test results seems very promising when we use this technology. So we think it might be a promising option in the future to interconnect more decentralized distributed generators into our system without expanding or replacing our assets. That would be an economic way to do this part of the job. Thanks for this question.
You're much welcome on these. And let me, since you are on screen, then I will come back to you as well. But I cannot avoid reflecting that the global pandemics started 2 years ago, as a matter of fact, and it is obvious to ask you maybe. What has been the impact, the real impact in your country of the COVID-19 pandemic on the development and on the investments in the distribution grids? Because that is something that we tackled a lot as an association and as European distributors. And but since you are here, I would like you to take this question, if you may.
Okay. Generally, I think the COVID-19 pandemic, we believe it brings us a lot of impacts from different aspects, the society level, the energy sector, our system, etc. And I think this is also a big question for me, and I would like to give you some examples for this question. For example, for system maintenance and asset management, we used to conduct these kind of jobs, use our engineers. They will go into the fields to inspect our assets or make some repairment on these assets. But due to the pandemic, we have to make these works more efficiently, because sometimes the people can't go to the fields to do these kind of works. So currently we are installing more phases, more online condition monitoring devices for this kind of equipment. And this is also one part of digitalization of our system. We think in the future, or in a distant dream, I think finally the whole distribution system will be operated by a machine. The least labors, but the most are our computers to do different kinds of work, including system operation and control, online monitoring, inspection, and everything. They will run automatically. So I think one thing the pandemic has have driven us to move this kind of future, I think.
Well, this is very interesting, and I do thank you very much for the availability to answer the question. And the other panelists have got something to note on this. Did COVID impact on your investment strategy? Just a very short answer. Ganesh?
So yes, it did. I think the major focus in the last 2 years has been on cash flow. So because there's been a huge reduction in demand due to COVID, particularly commercial and industrial demand has not yet picked up to pre-COVID levels. It is better than last year, but it has not yet reached 2019 or 2020 levels. So obviously the big focus. So as I think some of the things that we have slowed down a bit, like we had to slow down on our smart meter program because the higher capital investment for the smart meters is something that we felt from a cash flow perspective, it is important for us to balance the risk that we have. Also some of the network expansion, which because the demand has changed. So the network, the growth that we see in different pockets has changed with the shift in demand. So the investments that were in the pipeline to some extent have changed because industrial pocket has substantially lower demand now, and I don't need to augment that network as opposed to a business base case or business as usual. I would have had to augment that network in 2-3 years time. So those are some of the changes that have happened. So we become I would say more financially conservative or focus on cash, which has been the most important fallout of COVID.
Thank you very much,
Ganesh. Also, just to add on, I think the regulator has also been very, I would say, conscious that any tariff increase in this environment is very challenging for the public. So that also has played a part in cutting down our investments as well.
Ikeda-san, may I extend you this question as well? There has been any impact in the investments of Japanese distribution grids, in your opinion?
In Japan, as much as I know, it hasn't caused so much problem, the COVID-19, or it hasn't affected so much. But for a couple of the projects, we had to maybe postpone, or the project must be delayed. Like, for example, we have a project in one of the island. We have a project to operate that one island with 100% photovoltaic energy sources. But that island is one of the World Heritage. And we couldn't get into the island because of COVID-19 could affect the species on that island. So we had to delay the project. And we were planned to start that 100% DER operation by maybe 2023 at the beginning, I suppose. But it had to delay for like 2 years because of the COVID-19. So it does affect a little, but it's not that big.
Thank you. Mr. Chung, the same question for you.
Korea has a little bit same story in Japan. COVID-19 is not blocked our country, any area, just restrict our work and actions. And so power demand just a little bit decreased rather than other years. And so the investment is similar and with the regular basis. And the other issue of this year is organized in our country. Human safety on the power sector is very important issue. So our government and our company invest more in human workers' safety during the construction or managing our power system. And another investment issue is, as you know, today's subject, carbon neutrality. So our company, our country is planning to invest 69 billion euro in energy system innovation. It includes the breakthrough expansion of renewable energy and the preemptive expansion of the power grid in response of jumping renewable and distributed energy resources. And KEPCO is allocating the budget of 20 million euro to E.DSO demonstration project in Jeju Island. Okay, the pandemic and COVID is not affected our investment plan, but other issues, safety issues and carbon neutrality issues increase our investment. Thank you.
Thank you very much. But let me take advantage of you, Dr. Chang Hoon-Shin, which is the following question I would like to put you. In terms of investment and investment planning, your country has always been proving quite interesting when it comes to infrastructures. And can you tell us something on the plans for the carbon neutrality and energy transition and grid innovation, these three things that go together very much, of your government, of the Korean government, and obviously yours if it is not financially confidential, of course. I think that this island experiment will be a part of the investment, but on the modernization and advance the maintenance and resilience of the rest of the grid, what are the plans? And how can you think to comply adequately in a quick way with the notion of reduced emissions and reduce the carbon print anyway?
Okay. So the government invest is a common area, and also government improves new market system to participate many civil companies in our power system industry. And so the expenditure for carbon neutrality is very tremendous, we think. So government first they invest common areas to facilitate other sectors and civil areas. And then, for example, the Jeju Island project, many civilized companies are participating for flexibility solutions. For example, vehicle to grid and power to heat, and the plus there to mitigating the curtailment of renewable energy. So diverse models of business are experimented, and more public and civilized area investment will be added. So at this moment, the expenditure is not perfectly calculated for carbon neutrality, but we can step by step following simultaneously accepting carbon neutrality and economic creation and growth. Thank you.
Thank you. Absolutely. Then thank you for your openness in these. So I have a more general question for all of you, which banks also on these answer that has been given. So, in your opinion, for all, does the carbonization strategy include a major element of integrating the customer and the customer technologies? So do you go for a coupling of technologies with customers' technologies, first of all? And are you investing in new platforms for your distribution management systems to support all of these? So what part of these decarbonization strategy investments is working with the customers in effect? Who wants to take the floor here? We lost India on our way.
Okay, Mr. Roberto.
Yep, please.
I'd like to introduce KEPCO cases. There is a research project to handling public resources. To facilitate, we develop new distribution operation systems, as you know, advanced distribution management system last year. That was developed by the joint project through the 5-year project through many other KEPCO and other makers and solution providers. This provides more situational awareness and controllability of other resources. So we experimentally tested our own company's resources. For example, ESS and the other radiating load. But we are to plan to accepting other area resources for other companies' resource and civilize the resource through the contract-based operation. For example, electrical vehicle, we are gathering customers to participate their car to integrate our network. So our company provide the V2G ready charging infrastructure, and the customers provide their cars. So this kind of manner is electrified and mobilized in our system. I'm sorry, but many things is not clear. We have to more sophisticated solutions and functions to accommodate this kind of resources in the near future. Thank you.
Thank you very much for this. Any further notation from Yue Shang or Ikeda-san?
Mr. Roberto, thanks for your question. I think grid and customer interaction is a sure thing in the future. And we are actively preparing for this paradigm in the future. And one thing we are doing now is, just like I mentioned, because many customer-set devices, such as power electronics devices in the energy production sector, also like electric vehicle charging piles are massively connecting to our distribution systems. But our observability and controllability of our system is still needs to be upgraded to make the interaction capability stronger. So now we are implementing many we call intelligent terminal unit in our distribution system. We install them like in the distribution transformers or in the points of common coupling. These terminals has the ability to communicate and intelligent computing. It's just like our smartphones, but they are installed in our system. We can install remotely different applications into these intelligent terminals, which support us to monitor the customer set devices and even control them if necessary. And this is one thing. We believe if we have more ability of observing our grids and our customers, we can implement more and more innovative techniques from operation and control and market set to build we call an energy internet in the future.
This is extremely interesting, and I have got a question that is already in the chat, but it can be related to your last answer. And then, Dr. Shang, I would like to go more in depth with you and maybe with the other panelists if they would like on the notion of zero trust. But the first answer, also very brief if possible, is that we have got a good friend, Sarah Uxio, from ENGIE, a Belgian distributor, ENGIE Impact in reality, that says, I can witness in my European country a slow development of smart meter, which hinders the agile development of DSOs in quite contradiction with the rapid development of prosumers and electric cars. In all your projects, how do you value the smart meter penetration and necessity? Is this a real prerequisite for achieving a better and smarter management of the grids in your countries as well? This was for Chang Wuxin and Yu Shang, and obviously also Ikeda-san, if they want.
Okay. Smart meter deployment in Korea is strongly proceeding now. Our country is targeting 200 million smart meters. That is equivalent to the householders number. Now, 50% of the target is already deployed. There are many communication technology improvement was acquired through the past 10 years. At the first, there are many so wireless and 5G and the optical fiber is applied to the AMI infrastructure. And nowadays, edge computing and some intelligent functions are inserted in the AMI. For example, diverse price policy are implemented through remotely in each smart meters. And so finally, we are KEPCO want to diverse price policies for accepting and engaging customers and eventually they are participating carbon neutrality movement, and also they can get a better price policies. So Korean AMI deployment going to the 100% in 5 more years. Finally, and more flexible price and service solutions will be provided for engaging our customers and accepting carbon neutrality target in Korea. Thank you.
Thank you very much. But it is something that is very interesting, maybe to elaborate your launching there a point on what could be the role with energy internet, as you did in your intervention there. Do you think that Internet 3.0 concept could be an evolution for the applications to DSO? I know it is quite specific, but certainly it could be just a yes or no, or maybe let's see. As it is not the place probably for a technical detailed answer here. But maybe this is something that could be demonstrated on your magic island. And I am sure that many of the operators around the table here are very much jealous of the toy of having an island where to experiment the new market models and technologies in the same time. And do you think that this smart meter connectivity will take advantage from a revised internet such as Internet 3.0 in the future? All these hints are coming graciously and thankfully from Mark McGranahan, whom was very, very much impressed about the notion that started with Trust Zero, on which we shall conclude this debate. But please, do you have an answer to this? Internet 3.0, is that an advantage for DSO? It is an advantage in the connectivity between grids and the operators and the internet. And do you think this could be demonstrated on your magic island? This was the question. Who is going to answer? Mr. Chang? Chang Ushin? What is there something that is not clear?
Yes, I do not clear notion of Internet 3.0.
Okay.
I think Internet is by means of Internet, we can increase more situational awareness and controllability because DSO phase 1 to phase 2 and phase 3, we have more connectivities and entities and resources to connect together in our operational infrastructure. So more and more connectivity and more speed of the communication is required to support DSO enhancement. Yeah, this is my thinking of your question.
Okay, thank you very much for this. Does there is just a last stimulus here. Is this zero trust approach in cybersecurity for the grids the real turning point? Is that the first and foremost priority that you think is to be pursued in the evolution and the digitalization of our grids? The question is for all of you. Maybe we can start with Mr. Shang. Do you think that this zero trust approach on the grids in terms of cybersecurity is the turning point for an accelerated digitalization in the electricity distribution?
Okay, thanks for this question, Mr. Roberto. I think it seems, now to me, it seems very promising. Let me give you an example. We are now launching a research program to implement zero trust based cybersecurity technology into our grids, because we used to make our cybersecurity using hardwares like security chips in our terminals and the internet in our distribution grid is closed form. But now, because we want to interact more actively with our customers, our prosumers, so if we implement all of these hardware terminals, it will be such a high cost that we may not afford it. So because this the zero trust technology has already been proven by different internet companies like Google, like Baidu in China. They actually works. So we think it might be a very promising technology to help us to break the closed form network into an open network with affordable cost and prevent risks in our system. Roberto.
Thank you very much, Yue Shang. And I think that, as I said, this has already triggered a lot of reasoning also in parallel chats that I'm following on my network and in my WhatsApp contacts here. What is your opinion on these, Mr. Chang Gungshin, if you have? Mr. Chang Gungshin apparently has got a problem in the connection. And Ikeda-san, have you got a sensation on the zero trust as an element that is basic for cybersecurity?
Yes. So far in TEPCO PG, or probably all the power companies in Japan, has their own communication lines for their equipment so far. And I haven't heard of any ideas of connecting the equipment to the internet so far. But if that internet 3.0 and zero trust is really secure and really sure that those data are really secured, it would be great. that like smart meters and all the equipment are connected to the internet, because we will be able to handle a lot of data really quickly. So
Okay.
yeah.
Thank you very much. So let me, 12:03, let me tell, first of all, thank all of you on the panel, even if we have lost for technical reason of his bandwidth. I am told here, Mr. Changung Shin, and even if we have lost for previous engagement, Ganesh from India, very insightful as well. I would like to thank you, the two of you, for your availability this morning at least, this afternoon for you, in this debate. And I would like to tell you that your intervention has been really appreciated. You can see on the chat the interest that you raised on this, and thank you very much for some inspirational points that you have provided. This discussion of today will be shortly reported also for the next sessions, and thank you very much. On the back of the screen for the moment, the staff with of E.DSO and EPRI, and before I forget, the valuable contribution from Mark and Paul Wilczek, from respectively from EPRI Europe and Eurelectric, in helping with this discussion. I have the pleasure also to announce that Laura Cozzi, Chief Energy Modeler at the International Energy Agency, has agreed to reach us a bit earlier for her conclusions. And because surprisingly, in the debates that I moderate, this one has been very much concise. And so we are really in advance on our timing. Thank you very much, Changung Shin, for having reconnected. I extend you the thanks for having participated to this debate, and I've brought the insightful elements from Korea. I think that your island will be the topic for the chatter in the next few days among our communities, and I would like to come back to you for more details on this in due course. So I was saying that Laura Cozzi from the International Energy Agency, she is the chief modeler there in Paris. And the International Energy Agency is the author every year of that wonderful book, which is the Energy Report. The Energy Report 2021 has just been published, and is being presented around Europe and the world, I would say, in these days or weeks. Laura, you will tell us. But now, please take the floor for your conclusions. I know that you have devoted much of your efforts in 2021's analysis on the distribution grid. We had already the occasion to go more in depth in this, but please, we are really interested in hearing your conclusions.
Thank you very much, Roberto, for this invitation, and many thanks to E.DSO for inviting the IEA to this meeting. I had the pleasure to follow some of the discussion this morning, and I can certainly say that I am the person among all of you that knows the least about distribution networks, but hopefully I will be able to give you a bit of a broader perspective of what the distribution network mean in today's energy system, and in driving this global transition to net zero. Before starting with the slides, I would like to reflect with all of you on the starting point. And the starting point is really what has been agreed in Glasgow. We entered into a COP discussion in November last year, where energy-related emissions were more or less plateauing, but expected to then rebound and lead the world to an increase in temperature of around 3 degrees. Now, we are coming out of Glasgow with the pledges that Europe has made, Korea, China, India, the US. If you put them all together, if countries deliver on what they have promised in Glasgow, well, for the first time, the world will be leading towards a temperature increase below 2 degrees. So going into the high end of what was agreed 6 years ago in Paris. And sometimes I think we need to stop 1 second and reflect upon something that we may be able to experience this very decade, which is for the first time as humanity, we would be able to support a growing economy and starting seeing CO2 emissions going down. Now, promises are promises. The reality and hard truths of life sometimes are different. So what I would like to focus on the next 10 minutes is the following. Where are we really going? And what do we need to do to meet these promises? And where the distribution networks sit in this big energy transition we are witnessing. So I will now start sharing the slides and do the following. I will start with the following, starting with electricity. We always say, and we often hear that electrification is really the mantra for the future, and we do completely agree. Now, sometimes what we don't really capture is the magnitude of the change we may be having in front of us in terms of electricity demand growth. So what you're seeing here is not a forecast. This is where we would need to be if we were fully complying with getting to net zero by 2050. So what we have agreed in Paris, a step change compared to what we have actually been seeing in our advanced economies, where demand for electricity has actually plateaued for the past several years after 2008, basically, and very different from the demand growth, the pace of demand growth we are seeing and experiencing today in emerging economies. So a step change in this electricity demand. Where is it coming from? This is coming from a few sectors, which I would like to show you here. So why we are not expecting a huge increase in demand in the building sector, despite the fact that today we still have 800 million people not having access to electricity. 1 in 2 people in Africa, I would like to remind today, still don't have access to electricity. So a huge work that we still need to do there. The largest amount of increase in electricity demand we are expecting is coming from transport. We are seeing in Europe last year, 2021, our data show 10% on average of new cars sold were electric. In China, data for November showed that 20% of the sales in China of new cars were electric. And this is something that we are expecting to see and just continue to grow. This is changing the way we use electricity, are very different loads than the one that you are used to see normally, and is going to see a change in profile in demand growth in Europe, in China, in India, and elsewhere. Key uncertainty for all of us is how quickly this will happen, and something that is difficult, this uncertainty, a new uncertainty on when these cars are going to be charged and how the distribution and the networks in general will need to adapt to these new loads. The other big change is hydrogen production and electrolyzers that will actually feed this hydrogen production. Another big rise for us in terms of new demand growth, as long and at the same time electricity on 2 things actually that I would like to pinpoint. Some of this electricity will actually eat up some of the demand that is currently met by gas for lower temperature heat, and increasing demand for electricity intensive products such as aluminium, where we're seeing increasing, because of the energy transition, increasing demand. So here electrification becomes keyword, but with new challenges in terms of amount of loads and how quickly this demand will grow. It's not a question of whether it will grow faster than it has in the past decade, but how quickly will we manage this electrification. Now, what are the challenges? The challenges for us are first and foremost an investment one. If you focus on the power sector alone, we are investing less than half. In fact, we would need to double plus 50%, 2.5 times current investment in the power sector, including networks. We are seeing this being insufficient everywhere, being insufficient in advanced economies, being insufficient in emerging economies. We are not talking about this, not nearly enough. So where do we need to invest? Now, focusing on the power sector, I would like to show and focus your attention on the pie chart there. We hear all the time, and luckily and very good, we always hear newspapers, politicians talking very much about the big success of renewables, which is a great story. Most of renewables today being competitive, huge progress made there in terms of clean energy transition. What we hear very little is the amount of new investments we need in grids. And if you look there, in fact, grids, networks, transmission, distribution is the largest portion of new investment needed to make sure that this transition happens. This is not a very popular subject of conversation. Very rarely you see the grids topic being discussed on newspapers. Increasingly, we are trying to push a bit of an alarm bell to politicians. Make sure that you have the right market design in place to attract this huge amount of new investments. Otherwise, grids may well become the brake to this clean energy transition. Why? Keep in mind one very simple number. If you are to install a solar park, you may need around 3 years. If you're planning transmission networks or distribution work, this may take up to 10 years. You have a mismatch there. So the planning and a more cohesive way of looking at the transition is going to be needed soon. Especially, I underline this, the investments to make sure that the regulatory framework are there to make sure that the new investments are flowing in a timely manner. Let's deep dive a bit more in these grids investments. Now, I don't want you to focus very much on the amount, but on the change that are needed. So here you see many different slides and colors. I'd like you to focus on the yellow bars, because the yellow bars is a scenario which is compatible with what has been agreed in Glasgow. So what we have agreed in Glasgow basically implies a 50% growth in investments needed annually on average globally in distribution networks. If we look at whether this money is about to flow, unfortunately, the answer is no. For a variety of reasons, the change between emerging economies and advanced economies, but again, market designs and the attention of policymakers to this issue is not yet there. So for us, this is a critical alarm bell. And if you look at the mismatch, we see clearly seeing a larger mismatch in emerging and developing economies, where electricity demand is going to grow the most, where capacity expansion is going to grow the most. But in advanced economies, we see emerging issues as well, because we need more investment in distribution and transmission networks for 3 critical reasons: maintenance and making sure that we have heard cybersecurity earlier. For us, this is becoming a critical issue. So new investment is in making sure that there is a grid upgrades, that there is a grid maintenance and digitalization made at the same time. Those investments seem to be #1 priority. Second, as electricity demand starts picking up again, we will need more of those investments because of more demand. And third, the increased amount of variable renewable in the systems in Europe and elsewhere will demand more of those investments going forward. So filling this shortfall is going to be of paramount importance very, very quickly. Now, I would like to talk about two other issues that we are seeing coming under, importantly, under the radar screen. All orderly transitions require a very important amount of critical minerals, and grids are not an exception here. When we look at the amount of demand for critical minerals around the world, this is growing very quickly. And we do see a potential mismatch between the amount of critical minerals needed throughout the clean energy value chain, grids, but also electric vehicles, but also renewables, and the fact that those are relatively concentrated, and a possibility that the demand for these minerals will create mismatch with supply at certain points. So for us, the new energy security paradigm will certainly have electricity and the grids being really the blood network to make this all work. But we will see also an increasing need to look at critical minerals going forward. And we are really trying to raise awareness on this issue. Now, a concluding point is about what you can see as an enormous possible opportunity going forward, and is about job creations. But it comes with a warning. So when we look at the net impact of how globally, in Europe, the numbers are very similar. The global clean energy transition, how will it change the workforce that we have currently in energy? What we see is an important net increase. Although we ring a bit of the alarm bell on some job losses that may occur in coal, oil and gas related communities, I would like to focus here on the huge amount of new jobs that we may be creating to install new electricity capacity, mostly renewables. But importantly, most of the increase that you see there in the blue line is actually coming for networks. Now, there is a huge opportunity. So all of you working in this space, in distribution and in transmission, you have a talent force that you have with you. And I would like to say that if the distribution is really the blood network for the clean energy transition, then the talent you have with you is like the blood cells that are navigating in this energy transition. Now, do we have enough of these blood cells, and are they the right blood cells? And what we see is a bit of a mismatch here. So I'd like to warn all of you, and especially those of you that are at the heads of those organizations, nurture your talents. Make sure that you prepare a new pipeline of talents coming in with new skills on cyber, on digital, that are higher skills than the normal one that the industry has deployed up to now. And importantly, start training the next generation of people that will come and work with you. So we see here a huge opportunity in terms of job creation across many geographies. But when we look at the skill profile that we currently have in the network industry and what may be needed going forward, we do see a bit of a mismatch there. And importantly, when we look at the lineup of who is coming out of university now, who is the pool of next generations, I would like to say here another watch out. So critically for us, the network is distribution network, transmission network. Both of them, I'd say, are very much being not spoke about enough at all levels, but are going to be critically important for the successful transition to net zero. We do have a real opportunity. We have never had it as humanity, as human being, as we have it now with the technologies that we have today. But 2-3 alarm bells. The first one, again, to wrap up on investment. I urge all of you to work more closely with policymakers to make sure that the market designs, the tariffs, the investment incentives are there to make sure that we expand, modernize, and make cyber-proof all our distribution networks. I would like to dismantle forever the idea that the false debate that has been in place for some time, in which going for renewables would have needed no more investment in transmission and distribution. We should stop that and just focus on the incremental new investment. Second, watch out for and working in collaboration with other relevant actors on the critical mineral side to make sure that you have the materials going forward to make sure the transition happens. And third and final, please nurture your talents, the current one and the future one. And I wish you all really a very, very good conversation going forward, just underlining even more the centrality of the work you are all doing. Thank you.
Laura, thank you very much for your, I quote, wonderful agency presentation, helpful for all distribution system operators and all members of E.DSO. This comes from our chairman, Christian Buchel, whom I would kindly ask on the screen to share with me the salutation and the closure of this first session of the E.DSO platform. Christian, please have the floor.
Yes, thank you very much. It was not foreseen, but thank you very much, Laura, for this fascinating presentation, yes, which give us, I would say, not only a flavor, but the reality of the magnitude, yes, of all the aspects you mentioned. Very impressive. Thanks to all contributors, yes, for testimony, for exchanges you had this morning. I think it was, Roberto just said, helpful, yes. I think it's for us an input we do need as companies, but also as CEOs or managers to tackle all the challenges we have to tackle in these days and for the future. And as Laura rightly say, I share this, yes. There are also ring bells, you said, Laura, yes, about investments, about access to minerals, about access to talents. We share this. Thank you very much. May I add another ring bell is how it is acceptable and affordable for the end consumer, yes, because energy transition, I opened this session with the general environment in the world about prices, energy prices, and we have also as a significant part of the industry to contribute to this, yes, to make the system as a whole affordable and acceptable for the society and the citizen. So thank you all for this session. It was very wonderful, and once again, thanks Roberto, E.DSO, Eurelectric, EPRI, and all those who prepared this wonderful event. Thanks.
Thank you very much, Christian. Thank you, Laura, officially in closure of this. And to all of our participants, we have lost some, as it happens, along the morning. We are, as I said, shorter by some 10 minutes on the schedule, but I'm happy about that. And the session 2 is resuming at 1600 hours Central European time, with a strong view on the elements of resilience and grid modernization and the subsequent expanding prosumer market. We shall have quite a lineup there, and we shall go into North American experiences and South American experiences. And this is also the reason for resuming at 1600 hours Central European time. The session will be moderated by Mark McGranagan, and the conclusions will be drawn by Christian Ruby, Secretary General of Eurelectric. So see you in a few hours, and thank you very much for your participation this morning.